Okay, what makes calculus challenging for students? Generally, it's the algebra and not the calculus. So here are three things that we're going to look at that are going to help us out with the algebra. 1, factoring patterns. 2, what is a conjugate factor and what are their products? 3, how to simplify complex fractions. These are all going to be important when we work on limits. So the first thing we're going to look at, I'm not going to do all these for you, but I want you to maybe pause the video and take a look and see what's happening here. In the left-hand column, we have 2 factors that I want you to multiply or expand. When I say that, I mean do the FOIL process. First, outer, inner, last, to expand and get a polynomial in standard form. What's a polynomial in standard form? Look at the column on the right. These are polynomials in standard form, where the leading term is the highest degree, and the degrees go or decrease as you go down the line till you get to the constant. Okay, in the middle of the column is the factoring pattern that I would like you to be very familiar with. So a squared minus b squared. This is called a difference of squares because we have 2 squares that are being subtracted from each other. So there's a difference of squares. Then we have a square of a difference and a square of a sum. A squared minus 2ab plus b squared is the square of a difference. We should recognize that product as a minus b squared. Okay? A plus b squared. Right? So here's my sum, it's being squared. Here was my difference, it's being squared. So give those practice problems a try. All right, next we have 3 more practice problems. One is expanding, again on the left, factoring on the right, and the pattern in the middle. So the first one is the sum of cubes. Here I have 2 cubes, a cubed plus b cubed. I'm adding them together. Difference of cubes, a cubed minus b cubed. Notice in both of these patterns, the first factor is a plus b, when it's a cubed plus b cubed, and the second factor is a quadratic that cannot be factored. Difference of cubes, a cubed minus b cubed. The first factor is a minus b. The second factor is a quadratic that cannot be factored. Okay, the last one on this page is factor by grouping. If we group the first 2 terms together and the second 2 terms together and factor the common factor from each of those sets, factoring c from the first set, factoring d from the second set, notice after that we have a common factor in both of the 2 terms, the first term and the second term, which we're going to factor or undistribute, leaving us with c plus d as the other factor. So factor by grouping also comes in handy when you're not sure what to do. Last 2 factoring and expanding patterns. The first one is x plus 3 cubed or a plus b cubed. So the cube of a sum. That turns out to be 1a. That should be a cubed, my apologies. Cubed plus 3a squared b plus 3ab squared plus 1b cubed. Okay, so we should start recognizing the sum of cubes, the difference of cubes. Those probably aren't going to come up as much as some of the others, but just in case. Okay, you might also remember the binomial expansion and Pascal's triangle coefficients. So if I have a plus b to the 0, that's just 1. A plus b to the first, that's just 1a plus 1b. The blue coefficients in this list here, as I go down the triangle, are the Pascal triangle numbers. They become the coefficients when you do the binomial expansion. So take a look at that pattern, see if you could figure out what is a plus b to the 5th. All right, moving on, we're going to take a look at a new topic called conjugate factors. So in the factoring patterns, you saw some conjugate factors, a plus b and a minus b. Here are 2 factors, they are conjugates. Remember, a factor times a factor is a product. All right, so we're going to look at conjugate factors and their products. All right, so a minus b, a plus b, those are conjugate factors. What's the difference? Basically, this plus sign. They look exactly the same, except the plus and the minus. All right, what happens when you multiply a plus b times a minus b? If we do the FOIL process, a squared minus ab, that was first, and then outer, and then inner, and then last. Notice what happens with the outer and the inner terms. They drop out. So we're left with a squared minus b squared. Super. This is so easy. So if I have a plus z times a minus z, z, guess what I get? A squared minus z squared. Okay, that was pretty bad. Let's leave that aside. Let's move on. Why do we need conjugate factors? Sometimes we need conjugate factors to make a messy expression simpler, okay? You might not think that now, but when we work on some other problems, you will recognize why. So first of all, there's another reason. You know, there's an old dead math dude rolling over in his grave because in these first two examples here, I have a square root in the denominator, and whoa, that's not a good thing. I don't really care, but some old dead math dude does. So look at this one, 1 over the square root of 2. How did you get rid of that square root of 2? You multiplied the numerator and the denominator by the square root of 2. And lo and behold, you don't have a square root in the denominator anymore. That's all well and good. How do we do it with example number 1, where we have 1 plus the square root of 3 in the denominator? Well, we're going to use a conjugate factor. So let's multiply 1 minus the square root of 3 by the numerator and the denominator. Why do it to both? Well, because you have to leave the expression the same value, right? It cannot change numerical value. So if I multiply by the conjugate factors in the form of 1, I've not changed the value of the expression. So 1 minus the square root of 3 over 1 minus the square root of 3 is just 1. Okay, what happens when we multiply? Well, the numerator, not much. You're just going to leave it as 1 times 1 minus the square root of 3. The denominator, those are conjugate factors. What happens when you multiply conjugate factors? You get the first thing squared minus the second thing squared. What's the square root of 3 times the square root of 3? Yep, it's just 3. Let's simplify that. We get 1 minus the square root of 3 over negative 2. I don't like all these negatives, so I'm just going to make it negative 1 plus the square root of 3 over 2. Sounds good to me. All right, next. Example number 2. I have 2 minus the square root of 5 in the denominator. I'm going to multiply both the numerator and denominator by the conjugate factor, 2 plus the square root of x plus 5. 2 plus the square root of x plus 5. Always multiply out the conjugates. You did that, you chose that for a reason. Always multiply out the conjugates. What happens in the denominator? We get 4 minus the quantity x plus 5. In the numerator, you don't have to multiply out the numerator. You could, but you don't have to. And so let's just simplify the denominator and call this 4 minus x minus 5. What is that? 4 minus x minus 5. That's negative x minus 1. And in the numerator, 3 times 2 plus the square root of x plus 5. Again, the denominator has a lot of negative stuff going on, so I'm just going to pull a negative up to the numerator and call it x plus 1 in the denominator. Okay, the next two examples. Oh, trig, your favorite. So, what is the conjugate of 1 minus sine of x? 1 plus sine of x. I'm going to multiply both numerator and denominator by the conjugate. So the numerator, I just get 1 plus sine of x. In the denominator, when I multiply that out, I get 1 minus sine squared x. What is 1 minus sine squared x? If you don't remember your Pythagorean trig identities, you'll be working on them soon. That's cosine squared x. Okay, next one. Secant x plus tangent x. The conjugate is secant x minus tangent x. I'll multiply both numerator and denominator by the conjugate. What is secant squared, or secant x plus tangent x times secant x minus tangent x. That's secant squared x minus tangent squared x. Anybody know what that is? Anyone? That happens to be 1. So 1 over secant x plus tangent x is the same as secant x minus tangent x. Okay, you can work on that in your spare time. Let's move on to complex fractions. So here we go, complex fractions. A complex fraction is when you have a fraction within a fraction. So if I have 1/3 minus 1/4 over 1/6 plus 1/2, okay, I look at all these denominators and I say, what is the least common denominator of 3, 4, 6, and 2? Well, I think it's just 12. Do you agree? What happens if I multiply the numerator by 12 and the denominator by 12? Keep in mind, I chose 12 because all of the denominators divide easily, evenly, into 12. So when I distribute and say, what is 1/3 of 12? Please don't tell me it's 12/3. Please tell me it's 4. And then I say minus 1/4 of 12. So what's 1/4 of 12? 4 goes into 12 evenly. That's minus 3. Boom. There are no more fractions in the numerator. They are gone because I multiplied by the least common denominator. Let's do the same in the denominator. Let's multiply 1/6 by 12 and 1/2 by 12. So 1/6 of 12 is 2. 1/2 of 12 is 6. And what do we have? We have a simple fraction. 4 minus 3 is 1. Over 2 plus 6 is 8. Done. I've eliminated fractions within fractions by multiplying by 1 in the form of the LCD over the LCD. Now let's do that with some rational expressions in terms of x. So here we go. The hardest part of this is knowing what is the LCD. Okay, what is the LCD? So let's look at the denominators. 6x squared, 6, 2x, and 3x squared. I need a expression that all of these factors will go into evenly. So it looks like the coefficients, 2, 3, and 6, will all go into 6 evenly. And let's see, I have x squared, no x is x, x squared. Okay, x squared. Will each one of these denominators go into 6x squared evenly? Yes. So I've found my least common denominator. What am I going to do? I'm going to multiply the numerator and denominator by 6x squared. Now, be careful that you actually see in here, we are subtracting fractions in the numerator and the denominator. Okay, let's multiply the first fraction by 6x squared. What do we get? Well, the denominator is 6x squared, so it's going to cancel with the 6x squared I multiply. I'm just going to get x squared plus 6x plus 15. Then I have minus 5 divided by 6 times 6x squared. The 6 in this denominator is going to reduce with the 6 of the 6x squared, and we're going to get minus 5 times x squared. Done. The numerator has no more fractions in it. Let's look at the denominator. Take 6x squared and divide by 2x, because 2x goes into 6x squared evenly. How many times? Right, 3x times. Then we have minus a 2, that's the numerator, minus 2, and 3x squared goes into 6x squared how many times? 2 times. Let's simplify. We're going to get negative 4x squared plus 6x plus 15 over 3x minus 4. All right, pretty much, I'm going to call that done. I can't do anything else with it. Okay, I am going to run out of time because I only have 15 minutes, and I have 2 more examples, number 2 and number 3, and so you should probably write those down. Find the least common denominator, first by factoring the denominators that you have, and then try this process of multiplying each fraction in the numerator and denominator by the least common denominator to simplify. We'll talk to you.